So I've been told that I am the guy standing between folks in happy hour. So that's a heavy burden to bear. So being cognizant of that, I'm going to try to be appropriately expeditious in getting through my presentation. But thank you for having me. And hopefully at the conclusion of this, I would have given, for some, perhaps a little bit more understanding about what artificial intelligence is. For most, hopefully, how it's being applied in healthcare. And for all, hopefully, an understanding of the things that we need to do to make sure that this technology, very powerful technology, is used the right way so we can maximize its benefits and mitigate its risks. So just a little bit about myself personally. So I am not a computer scientist. And you know, my background is in the life science field, and so I've been in healthcare for about 40 years in a variety of capacities. The vast majority of that has been spent in biomedical research. My doctorate is in biochemistry and molecular biology. And I'll give a little bit of background on how I've arrived at this space right here, which has been very disruptive and is impacting so much of what we do in the world today. So in addition to this organization, which I'll also tell you a bit about, NADPH, I'm also a lead MPI, and I help run, I'm actually the lead PI for the Data Infrastructure Core for the NIH AIM Ahead program, which is a program that is trying to increase participation and access to artificial intelligence in communities that are underserved and underrepresented. And helping them apply that to biomedical research to address health disparities. So just a little bit about myself. So let me dive on in. All right, so NADPH, we're a nonprofit organization. Our vision is that healthcare, good health, should be achieved and available to all, right? And we're really trying to democratize access to healthcare, but particularly the forces that are driving improvement in health. And so that being said, our mission is to eliminate health disparities, and we're going about this in a number of ways in terms of our strategic approach, and you'll hear a little bit about that today. A part of that is certainly improving representation from those communities that are underrepresented in healthcare and biomedical research and clinical practice. And again, and much of what we do, quite frankly, is based on evidence, quite frankly, and convening thought leaders and looking at what works best in terms of improving healthcare and making sure that we're successful at trying to treat disease and prevent it. We are also very involved in making sure that, as you can imagine, that there's equity in that work, and that we've got the inclusion, but also too in that the practices, the technology, the practices, the models are ethical. And that's something that right now is of extreme importance and concern. Health information is a very powerful commodity these days, as I'm sure you're all aware. Data in general is a commodity, and so you can't go anywhere without being asked to provide some type of information to get access to some type of service. And oftentimes, there's a level of trust, weighted trust around that allows us to be very presumptuous about the intention and their good intent, and we sometimes are ignoring of what some of the other downstream activities that are exploitative are. And so, again, we take a stance to try to really make sure that folks understand that, and very critical today as we are trying to navigate artificial intelligence. So that's basically, and you can see this, and I'll just advance and give you a brief overview about what health disparities are and why they're important. So generally speaking, health disparity is really any type of difference in health, the achievement of health or health outcome in one group versus another. And more importantly, that this outcome, the difference in the outcome, is largely believed to be preventable. All right, so that's what we really refer to when we talk about health disparities. So generally, the perception is and rightfully so, that these disparities occur mostly along racial and ethnic lines, and this is true. A disproportionate amount of that burden does reside in those groups, but again, they exist in other groups as well, in very powerful and significant ways, and those include gender, based on geography, and a variety of social demographic factors. And so from our perspective as an organization, our mission is really to address that wherever they exist. And then looking at that fundamentally, what we're really about is human discovery, and then trying to understand all of the factors that influence human health and the outcome of that health, and then looking at where there's disparity in obtaining that good health outcome. So why is this an important issue? So clearly, based on what I said, you can imagine that there's a moral compulsion around trying to address that, all right? Just the fact that you have groups that are not doing as well as others, for those of us who have a moral compass, I like to believe that as humans, basically, we were built with that, right? Whether we choose to ignore it or not, we get that. But that's not always incentive enough to get folks to do something about it. But what will do that is money. Dollars and cents, right? We're a capitalist society, and so that always moves the needle. So when we start to look at health disparities, well, right now today, those disparities in health outcomes, the inequities associated with this, account for about $320 billion worth of economic burden to the United States. And this projection is to be roughly $1 trillion in a short period of time, as you can see. So when we look at it from that standpoint, both morally and economically, this is a national crisis, right? And this is why you are seeing, changes and investments from a diverse array of stakeholders. So be they payers, be they providers, pharmaceutical companies, begrudgingly so, and then obviously federal health agencies. So this is truly a national crisis, and we need to bring everybody together to address this. And you're seeing that. So again, something that affects us all. So at NADPH, given our background in biomedical research and technology innovation, we see innovation in technology and some of the advances in medical science and the application of those, like precision medicine, as really at this time giving us the opportunity like no other time to bring resources that can help us identify and understand the factors that drive health disparities, but more importantly, to address them, right? And so that's, really what we're about. I really summed most of that up on this slide right here, but I just wanted to point out when I start to talk about the diversity of stakeholders. And so at the bottom, you can see some of the organizations that we work with, NIH, CDC, Robert Wood Johnson Foundation, and others, quite frankly. And so, and then taking this multidisciplinary approach to try and address this is again, what we're about. So let's start the transition into AI. So most folks, and I tell folks we're not your typical nonprofit, ask, hey, how do we get into this space? Well, about 10 years ago, I had the opportunity to be asked by folks at Northrop Grumman to come on board and help them build out a precision health business unit. And so this was this aspirational business unit that Northrop had, the health division at the time before they divested from healthcare, to try and apply this innovation and build a business model around that. And so I really had the opportunity to work with some very, very smart people, and it helped shape me because I got a chance to really become familiar and immersed in engineering principles and best practices, and that was profound in shaping how I would ultimately go on to approach NADPH. With this, we had a chance to really make some great accomplishments. So, as I said before, I'm not a programmer. My value to the team was really being as a customer, as an end user, right? And so, looking at how they wanted to approach, or how we could possibly approach applying artificial intelligence to biomedical research. That's really the value that I brought to the team in saying, hey, you know what, this is how we need to approach this. And so I began to assemble a team of engineers, developers, UI folks, and said, hey, people like myself in the laboratory, we got tons of data. Our expertise really goes as far as classical inferential statistics, right? But we'd love to be able to apply, artificial intelligence to our data sets. So here's the problem. I have to fund, have the money to bring in a bioinformaticist or a computer programmer into my lab to work with me to develop those algorithms, or I'm going to have the money to farm that out to a computational core. When I do that, it's in the queue. Right, and so, and that queue is running maybe 30 days for them to finally get to my data set and give me, results on my data. My data is getting stale, and that makes me less competitive in terms of publication, applying for grants. So wouldn't it be great if we can somehow customize this technology and put it in the hands of sort of the core population of users so that they can have access to this and be able to use it without knowing how to code? And great idea. And so when I got over to the NIH and talked to those folks, they were like, we love that. Can you do something like that for us? So that was really, my introduction into that and trying to help democratize access to artificial intelligence and get into healthcare. So here we were able to do some things. I think we were the first to demonstrate proof of concept to be able to process clinical and genomic data in the cloud using partnering with Google. And so that was a great accomplishment. So that really started to found the roots for AI within what ultimately would become NADPH. So what is artificial intelligence? So first of all, it's any computer or machine performing tasks that can be performed that would normally require human intelligence. And so if you're doing that with a machine on some level, then that essentially is artificial intelligence, right? There really are about 7 types of AI. And so I think what we know about AI, focuses or coalesces around a very small subset of these, and we'll talk about those, focus the discussion around those. But I wanted to just shed some light on the various types of AI, at least in principle and theory, that exists. Right, and so these are based on functionality and capabilities. And so, based on capabilities, there are really 3 types. Those are artificial narrow AI, general AI, and super AI. So for the purposes of this discussion and for your own benefit, generally the perception is it's believed that general AI and super AI are aspirational or things that are currently under development. The types of artificial intelligence that we encounter, that we're familiar with, really fall under the category of artificial narrow AI. And under that category of capability, functionally, the types of artificial narrow will be distinguished based on reactive machines AI and limited memory AI. And so I'm going to dive into those a little bit better just to make sure that folks have an understanding of the types of AI that we're actually encountering in the real world today. So as I said before, there are really 2 forms that are in practice today. All right, so reactive AI. And so this is more conventionally what we refer to as the machine learning. But really, any type of artificial intelligence, it's really based on training a machine. So, one could really consider it all machine learning. But the type of machine learning that we typically refer to is really classified under reactive AI. And so the distinction about this type of AI is that it really doesn't have any recollection beyond the period of computation, right? So whatever data you present for it to use and to perform its computational function on, that's the extent of it, right? And so it's a very specific, narrow task, but it can do that well, and this is the type of AI that's well suited for big data analytics, all right? And some of the big computational tasks that we come to use it for today, and we'll talk about some of that. And this is just based on statistical math and for the most part analyzing quantitative data. Some examples of the types of reactive AI that you're probably familiar with. One would be IBM's Deep Blue. And so for those of us old enough to remember when Deep Blue went up against Garry Kasparov, the grand master, chess master. And so he won the first one, but on the rematch, Deep Blue beat him. Deep Blue beat him. And so that was, that was a big moment in the field of AI to show that, hey, this type of machine learning could outperform humans. And so, we've never looked back since. Another example, a bit more modern day, would be search engines, right? And the real take home for this is that by training models and defining the rules for that model, you can basically apply that to make a decision or a prediction about an outcome. And so again, with search engines, with spam filters, this is what's happening, right? You give it the rule and say, hey, if this, then that, and that's basically, what's being used to reject or allow emails to get through. So those are two examples that most folks would be familiar with regarding reactive AI. So, excuse me about that on that slide. So healthcare potential for AI. So this is easy for me to talk about because this is really the primary way that I've used it throughout my career. And this is, again, big data analytics. And so providing a large array of data, multidimensional data. An example would be integrating an electronic health record data set, which is going to have more classical clinical data. So it will obviously have age, gender, but then also your clinical metrics, right? Laboratories, blood pressure, BMI, things like that. But then when we start to integrate that data with molecular data, right? And so increasingly now we're starting to use measurement of large arrays of biomolecules in your body, right, in blood. So proteins, genes, that's making its way into the data set. And so when we integrate that type of data along with clinical data, our ability to predict outcome, that power increases dramatically. And then when we start to add on social determinants of health, right, and environmental data, so the complexity of the data, the dimensionality of the data increases, and our power for prediction also improves. And so this is where reactive AI is really, really capable at. And so this is a major impact on healthcare, and I'll show some examples where that's being used to predict biomarkers, predict therapeutic response to a particular drug, and things like that. So that's really where the major healthcare potential for reactive AI lies at. The other form of narrow AI is limited memory AI, and this is probably something that you're even more familiar with. And so when we look at this, the distinction between limited memory AI and the reactive is that this actually has some limited recall, all right? And so you may have presented some data to this, and it has a limited corpus of knowledge that it can cross-compare with, right? And again, but that's very narrow, and so it can evaluate historical data, past events, and the types of applications that most of us are familiar with are going to be the virtual assistants and the chat boxes, right? And so Chat GPT, Alexa, Siri, these are things that I'd venture to say just about everyone in this room has heard of and probably even used, right? And so, and some of us may be familiar with it being referred to as generative AI, right? And the thing about this is that it can basically generate content, based on an input, and this is usually in response to some type of prompt from the user. And that content that it can generate, that can be images, that can be text, that can actually even be code itself, okay? And so a lot of talk about Chat GPT, and again, a lot of potential here. From a healthcare perspective, it can reduce computational requirements because it doesn't really take on the dimensionality or the volume of data. And so with that, you don't have to have that big data computational capability. You're really working with a narrower data set, and so the costs are going to be lower associated with that. And it's not as good as a complex task, obviously. And so that's something that has to be considered when using this from a healthcare perspective. And then difficulty in adapting and making generalizations. The one thing that's really important to point out to this is because limited memory AI really functions on a much smaller amount of data, it's not going to be as robust, right? And so the opportunity for bias to really come into play here is a greater risk for this type of AI. So that's one thing that needs to be understood about this. But again, still tremendous potential. Virtual healthcare is something that is just booming, and that has tremendous application in terms of addressing health disparities. I said that, geography is a big component of that, and so we start looking at people who are in more rural locations. Having access to these types of health applications are tremendous in terms of being able to get access to care. So there's a tremendous amount of potential for getting these types of narrow AI applications into the hands of populations. So tremendous healthcare application there. All right. So this is just, again, I just wanted to give an overview of some of the various areas of healthcare that AI in general has been speculated to have an impact on. This is really a survey of folks in the healthcare industry. This was put together, this is an amalgamation of 3 surveys from McKinsey, Deloitte, and I want to say Booz on this, where they surveyed folks in the healthcare field and as well as folks in the health technology space to get their opinions of where they really saw AI going in terms of healthcare, the real areas that they saw AI being able to have an impact in healthcare. So just wanted, and I won't go through this, but I wanted to show this, just for folks to get a sense of the scope of where folks see the technology being able to have an impact on healthcare. All right, so let's dive into a couple of areas. So voice, and this is something, and I included the references here in case anyone wanted to jot those down, and happy to share slides afterwards, but these are real applications of AI right now, okay? So right now, this technology is being used to analyze voice. So, and I don't think I need to tell you this, you experience it in your daily life. Kids, family, whatever, you get stressed, get angry, voice changes. All right, elevates or whatever, and everybody's changes differently, right? That's a real thing. Turns out, as you would imagine, all right, and again, you don't need any type of study to tell you this, you can feel the effect on your body when you're stressed or what have you. That correlates, right? So that change in voice absolutely correlates with physiological changes in your mental and emotional state. That's, the evidence base already shows that. So, as you would imagine, that is being used to predict things like, again, stroke, right? Cardiac events, okay? Again, and any type of, mental stress. So this is something that is in play right now, and it is expected to, to be more widely used, particularly through the form of AI we just talked about in the previous slide. And so if you can imagine now having a voice assistant, okay, that has access to trained models, right, to be able to analyze your voice and then, based on the training of that model, correlate that with a particular clinical condition and then be able to, place a call to a medical professional, right, an ambulance or something like that, because they can tell that you're at risk or get, cardiac onset or something like that. So, this is basically where the field is going in terms of voice analysis. So, just wanted to share that again, and this is stuff that's happening right now. Vision. This is also something that's happening right now. I'm providing a reference for you here to just see ways that AI is being used to promote what is referred to computer vision. And computer vision basically is anything that allows, is a machine being trained to detect, okay, some type of image, okay, and then to make some type of correlation about that image. So this is computer vision. The most wide application of this right now is really as a surgical assistance tool, right? And so what you're saying now is that as surgeries are being video recorded, those recordings are then fed into algorithms to train machines to determine what's a good outcome, right? Now, this obviously includes some natural intelligence, and that's natural intelligence, and so that's probably a good point to interject at this time. Any type of artificial intelligence really is only as good as the individuals that are training that, the data that you're feeding into it, right? And so that's really important to keep in mind here. And so, because there's a lot of fear and concern about AI taking over responsibilities, and again, about us losing control. And this is a real factor. It's a barrier to access and utilization, all right? And so it's really important to demystify, and we use that term because that's what we've received back from working with folks in the community, is to make sure that they understand what AI is, and then what is it really doing, right? So there's nothing about this that is operating or functioning on some type of principle or knowledge base that hasn't already been generated by human beings, right? And so we are the architects of this, and that's important for us to understand. And so it's only going to be as good as the underlying human input that designs it. So I just wanted to point that out. But again, so this is being used in several ways. It can, in this instance right here, you just see a couple of images where it's being used to look at the overall complexity of a surgical procedure and to see if perhaps this is something that can be taken on by a resident or needs of someone who's a bit more seasoned. And again, if you have a library of video footage across an array of skill sets in terms of surgeons, and can then look at those that had good surgical outcomes versus none, you can train the machine, right? And you can say, hey, based on the historical data, right, when it looks like this is something that, again, the model's been able to look at and see correlates with a poor outcome when a surgeon of 5 years or less of experience performs that, okay? And so this is something that we don't want to assign to a more junior surgeon. So these are the types of things that it's doing. It can actually help with localizing instruments, help with demarcating anatomical structures, all right? So here you can actually, based on the historical data, stratify tissue and actually assign it color, and in that instance really aid from a visual perspective so that the person coming in to do the surgery can visually distinguish a subanatomical structure. So again, these are just some of the ways that computer vision is aiding, and as I said before, it really primarily is being used in surgery right now. But also, it's being used in virtual reality as well to help train surgeons and folks do clinical procedures. So that's another area that computer vision is coming on board to support. So just interesting. This is really starting to proliferate throughout healthcare and really showing vast potential to help. So breast cancer detection. So this is something that's very close to my background. So most of my career has been spent as a molecular oncologist. Breast cancer is an area of oncology that I have a lot of expertise on and have worked to support in a variety of capacities. And so here, what you're seeing is more of the reactive model that we talked about. And so this is classical model training where you have a training set, a test set, and a validation set. Here we're looking at an imaging algorithm, which looking at pathology slides, right? So these are just basically slides of breast cancer tissue where the slides have been divided into a training set, a testing set, and then a validation set. And what you look to do is to make sure that after you've trained the model, right, and you see the training set in blue, when you test that in green, obviously you want the model to perform well and be able to predict the same outcome. So typically in something like this, you'd be looking at, okay, is this cancer versus non? Is this stage 4 versus stage 3? Or something else. And so you would have that outcome already, and you are retroactively training the model against that data set and seeing how well it can turn around and predict that outcome, right? And so you would, again, train, test, and then what you would want to do in the case of the yellow is cross-validate that against another data set, right? And it's because you want those models to be generalizable, meaning that if I train this model and it performs, can I then take that model and apply it in another environment against a set of data that looks exactly the same, but just from somewhere else? And does it perform to the same level as you performed in your other cases? And when you have that degree of generalizability, then you have a robust model that you want to go ahead and deploy. And then you've got something that you're ready to use and put into clinical practice. So I believe I have a reference here as well if someone's interested in looking at that, But this is just an example how a reactive AI model is being put into clinical practice, all right? And so, and this is, you know, and I can speak to this personally because this is stuff that I've done and my team have done. So this is a very real example of how AI is impacting healthcare. And so lastly would be an example of predicting clinical trial outcome. So very important, you know, the pharma is very interested in this, obviously. Pharmaceutical industry, it's a, you know, multi-trillion-dollar industry. The time it takes to get something, a blockbuster, to market is, you know, probably about $3 billion or so. And for everything that gets to market, you know, you've got tons of things that don't make it and millions, hundreds of millions of dollars of lost revenue. So they, you know, they want to get it right. And one of the ways that they are doing that is to use artificial intelligence to predict therapeutic outcome or response to a particular drug to determine, hey, is this something that needs to continue to be developed down the pipeline and go into market with? So this is just a very crude example, but this is real. And again, this is something that's been published where, you know, you have a raw data set and you have trained a model, a reactive model, as we've talked about. And that model now is able to, based on the outcome that you determine, that you know, as a success, right? And so that can be whatever the efficacy or the endpoints that define that. You know, I want to see, you know, a patient survive X amount of months without having any type of incident or any type of relapse. You know, whatever a clinician or a drug company would determine as a successful outcome is what you're asking it to predict. And so you're looking at those patients that met that outcome, and you're looking at things that correlate with that outcome and asking the model, say, hey, find me things that, that correlate with that outcome. So when I see it, I know, okay, there's a high probability that this patient is going to have the desired outcome under these circumstances. So essentially it, model being used to predict therapeutic response, and this is something that is in wide use today. Okay, so hopefully you've gotten a sense that AI has some benefit in healthcare, right? And this is a real thing. It is in wide use in some areas. In other areas, it is emerging, but it's the ship has sailed, and the commitments have been made, and it's being developed more robustly to help in certain aspects of healthcare. And so, as you would imagine, you know, again, tremendous investment being made by healthcare companies, you know, in this technology. And so this is just showing you the growth over a 2-year period. You know, the take-home message here is that we're seeing an increase in investment in AI in U.S. healthcare, right? So a lot of risk here, obviously. And so that happening, there's some things that healthcare companies and all stakeholders in AI really need to be cognizant of, and which is a real risk and threat to the successful implementation and application of this technology, and that is bias, right? And so this is a tremendous health risk. Some bias will always exist, right? And so it's just like efficiency. You know, 100% efficiency is theoretical, right? We never get there. There's always going to be some risk and bias because everyone has a view, right? We're not monolithic. And so, you know, people who are developing algorithms are not Autobots, they're not the same. And so based on those differences, there'll be some bias. So we won't be able to get rid of all of it, but we can certainly try to constrain and mitigate as much of it as possible. Some of the sources of bias, the input data itself, okay? So again, you know, user input, someone can make an error. It could be a typo, you know, in a flat file, all right? Or some type of error that makes its way into the data, okay, and causes it to be flawed. And so that, from that very initial input of data, you're introducing some type of bias. Someone could have, you know, mischaracterized a demographic heading, right, for a de-identified data set, right? Some type of input error that now gets codified and amplified in the model. Implicit bias. So, and this is what I was speaking to earlier. And right here, this gives an example of some of that bias. But the reality is that, again, as people, we're different. We have different backgrounds and different makeups and culturally. And so some of that can and does make its way into our perceptions. And so that type of implicit bias is something that we have to be careful of. And then lastly, another one that's very important is lack of diversity. And so a prime example of that would be in the previous case where we looked at the cancer drug, right? So if, as a pharmaceutical company, you have done your clinical research on a narrow population, that is, just monolithic and comes from the same gender base, same ethnic and race and racial base, and then turn around and you may have seen good efficacy of that drug in development and say it works in your rats, then you do your clinical trials and it works, but you again have that narrow population base. Well, when you get that to market in the real world, which is not going to be consistent of one narrow base, you're going to have a diverse population of folks, and you find out that it doesn't have the efficacy that you saw, when you tested it on a very narrow population base. Well, that's an example, right? And so your performance has been biased because you tested it on a very narrow group. And then when you put it out there in the real world, you see that it failed. And that can have profound repercussions from a safety perspective, right? You might have missed an adverse event or response to a drug that you would have captured, right? One group of people may respond to that drug differently, and you didn't catch that. And so you put it out there in the market, folks are getting sick, and you didn't realize that. But you could have caught that during clinical development if you just had included those folks in the population to begin with. So that's an example of where lack of diversity can have profound healthcare implications. So this is just an example here. I wanted to put this up here. So interestingly enough, in this group that was studied, the Black population, less money was just spent on that group for healthcare. And as such, the algorithm used healthcare costs, right, as a proxy for determining the need for healthcare. And so given the fact that there was less money spent, it felt that there was less care needed for that population. And so those patients who were at the same level of risk and needed attention didn't get it because the algorithm determined that they didn't need it because less money was spent on them. So again, that's just an example of where some of the bias can come in and have some consequence from a health perspective. All right, so how do we address that, right? So building trustworthy AI, because this is really important, and I'm going to tell you why. So one of the things that we've gotten really good at over the years is convening folks in the community across healthcare, right, industry, community organizations, health organizations, non-governmental organizations. And so NADPH has really gotten good working with stakeholders across the health ecosystem to understand barriers, facilitators, and what are the things that we need to be mindful of. And so what that told us is that it really is people over processes, right? Because AI, we'd already seen that a lot of the AI systems, the data platforms, had kind of been built from the top down, meaning that you got a bunch of computer scientists, bioinformaticists in the room, and they kind of said, hey, this is what's best. What wound up happening and spending hundreds of millions of dollars to build these platforms is that the broader community couldn't use them, right? And so again, if you didn't know how to code in Python and things like that, you really couldn't use them. And so, and this is something that, we learned from talking to people, right? And talking to folks in the government. So it really let us know that, again, people and processes, or people over processes. All right, so I'm gonna skip this one right here. And I'll just tell you that these are some of the factors that influence trust of clinical AI. And this is based on work that we've done, really, again, having everybody in the room and asking them, all right, what are the things that impact your trust of AI? What are the things that you're concerned about when it comes to AI? And I'll tell you, there's real disparity, heterogeneity in terms of the views on artificial intelligence, the knowledge base. And so we just cannot assume that everybody is moving forward with the same understanding of what this technology is and what it can do. So this is important. Trust me, you have to get this right and understand where the end users are, the folks that are going to be using this technology, what the views are. So community engagement. So it turns out, and I really appreciated this during my time at Northrop Grumman, this is really engineering practices 101, best practices 101. If you're going to build something, right, be it an AI platform, algorithm, what have you, you need to make sure that you've got critical end user input, right? So, and there's some folks in the room who know this, and there are sizable investments in market psychology, right? And these things to really understand the customer base, right? And so that right there tells you that, hey, if you're going to invest, a bunch of money and make a sizable investment in something that you expect people to use, well, you kind of need to consult the people that are going to use it, right? It makes sense. So, but you'd be surprised how that's not the case. That is not the case. So, and this is why, however intuitively obvious it might seem to folks, I had to put this up here. Turns out that as software development practices evolved over time, and we moved away from, and I learned this from Northrop Grumman, trust me, not from being a software developer, but I learned this from being at Northrop Grumman. So moving away from waterfall to more efficient practices for product development, software development, and incorporating this Agile Scrum methodology, when I started to look at it and understand what Agile Scrum is, it's like, hey, we've got this great project management framework, and it's really about staying in close contact with the end user and, not waiting long periods of time to get feedback. Let's iterate over these short cycles of time. But then when I got into the core values of this methodology, lo and behold, individuals and interactions over processes and tools, and then customer collaboration, right? And so you would be surprised in terms of making investments around technology, how some of the critical populations or communities are just not included, right? And so I wanted to highlight this. And then it turns out now, so if you look at any strategic, well, not even that, if you look at a commission that has been authorized by the president, right, of the United States of America, by highly credentialed bodies that are convened for thought leadership and recognized as experts in the field, the national academies for one, and where they've been commissioned to go out and bring back findings about what are the best ways to innovate around AI, artificial intelligence, right? The United States is losing its competitive edge in this space, right? As other countries really accelerate and get momentum around it. God bless you. And so two things stand out in this, and these are in strategic agendas across every federal agency. It's innovate around information technology, right, AI, but also it is diversity of inclusion across STEM and co-designing. Co-designing, meaning work with or across the continuum, work across the ecosystem. So don't just have your subject matter experts in the room pontificating and doing this stuff in a vacuum. Include the broader community, all right? And this is stuff that is codified in all of these reports and these findings, right? So this is a real thing. And so and it's important for anyone who is really serious about developing artificial intelligence and trying to apply it and get broad adoption of it. All right. So again, I'm going to just go over this. Is just so we've developed a framework, and the problem that I think folks have in wanting to do this or seeing the value, and I was there. I was one of those at one point. Is that underneath all of this is really, really hard qualitative research that's involved, right? So this type of deep engagement, and this is really, scientific work, right? And designing methodologies, synthesizing themes and outcomes from that qualitative research. And, that is not sort of viewed upon as favorably as some of the more hardcore quantitative sciences, right? And so I don't think it gets the appreciation that it needs. And my team, and so I do not lead this work, quite frankly. So I have an illustrious team, and I'll show you at the end, who does it, and I began to really appreciate the science behind this work. But that's what it really takes, engagement. And so that's surveys, that's interviews, synthesizing themes, and really understanding who it is that you're interacting with. So we've gotten really good at that, and so we apply this model, and this is just some examples of the deep engagement that we do. This is some work that was funded under the Robert Wood Johnson Foundation, where we're working with communities to understand where they're at in terms of things like AI and data resources and technology, and how to best work with them to ensure the design and implementation of these technologies like artificial intelligence can maximize the benefit to these communities and minimize the risk. And so this is really important. If you look at Biden's executive order on artificial intelligence, such an emphasis on this, trustworthy AI. So this technology will not be adopted, and it will not be successful unless this work is done. So in any event, these are some things, and you could certainly reach out to us to learn more about what we're doing in this space, but this is really important. And then you have to engineer this from the beginning. Again, good ethical and equity frameworks in terms of developing and testing the AI. So we've been able to do this work. We're doing it for and with NIH in this Aim Ahead program. So we were able to lead the development of an AI ethics and equity framework, again, through convening folks across the country, getting them together, getting them in the same room, hearing what they have to say, and then putting that qualitative assessment to identify what the themes were, what the values were, and then how do we incorporate that into technical design. Right, and so ultimately, this is, from doing this work, this is what we've done. And so this is our AI informatics platform called CEDAR, which is Community Engagement and Data Resource. And again, informed by all of that hard work that I talked about, because we wanted to make sure that whatever we built was just not going to recapitulate, the same challenges. One of the things that we heard is, again, like I said, folks want to use this stuff. They don't know how to code in Python. So how are you going to democratize access to this, right? Issues around the user interfaces. And, we're coming off of whether it's Genomic Data Commons, the Cancer Genomic Cloud. You look at the informatics infrastructure across NIH and other places, huge investments. And I know because I've talked to the heads of some of those ICs over there, and it's like, hey, we got a problem with that. Can you help us, democratize this? And so that's where the big push is. And some of that, what we were able to do is essentially create a no-code AI analysis engine inside this platform, so folks can get in here and they don't need to know how to code in Python, right? And then we've got concierge tech support where we help them with hypothesis formulation, data shaping, and getting it into the environment so that they can use this. So I think this is just another example. So for Aim Ahead, we've built this to specifically support minority serving institutions, HBCUs. So let me back up for a second. So we started out to build this and with the intent to support underrepresented, under-resourced institutions. It is accessible and available use for anyone in Aim Ahead. So I want to be clear about that, right? Our focus from a design perspective was around those institutions and trying to increase representation. But again, we're mindful of particularly the Supreme Court ruling. And so it was never the case to exclude anyone, and that is not the case. And it's just now the focus is not around specifically addressing under-resourced, represented institutions, again, because that just goes in the face of this ruling. And so we want to make sure that we're supportive of NIH and adhering to that. But this is what that looks like. So it can support anyone, but if you are under-resourced from a subject matter expertise perspective and really don't know how to navigate Python and those types of things, then you would find this type of platform particularly useful and helpful. So All right. This is just some examples of some of the work that we've published here, but I'm happy to share that with folks after the presentation, and feel free to reach out. And then lastly, I would like to thank my team here. And so you're looking at, so the people who lead that very important work I talked about, Malika Simmons, Dr. Rachel Hendricks-Stirrup, and Tammy Shepard, they really lead our community outreach and qualitative research division, so I'm very happy and proud of them. These handsome gents to the right, Mervyn Chapman, Dr. Ivan Cassidis, and Chuck Coppenrath, these are our tech team, members of our tech team. We got some folks on represented here, they're a bit shy. Mervyn is our Chief Information Security Officer, Dr. Cassidis is our Chief AI Officer, and Chuck is our Solution Enterprise Architect. And so Dr. Joseph directs our public health program, and we've got Latanya Bynum is one of our chief qualitative researchers. And then lastly, Jeannie and Kathy from Vitalink, they are part of our communications team through Vitalink. So on that note, I want to thank you for your time and attention, and I will try to address any questions you might have.
Hi, I have a question, actually.
Yes.
So there was a study out of Stanford and then also out of the UK's NHS I want to say about a year ago now, about the data inferencing of anonymized data. And so, you strip out all the patient data and then you throw it into a model with other open source information and whatnot. And after you train the model to do the analysis and however you want it to, what rules you want it to follow, they found that it was actually de-anonymizing the patient's records. Mm-hmm. And like with NHS, they had to pull everything offline because that's a huge overstep of UK law and whatnot. And then Stanford's found similar principles here that were HIPAA in the United States of HIPAA violation. So I know it's probably more of a question for your programmer, but is that being discussed like amongst your partners and other stakeholders?
It is actually. We just had a meeting with a tech company that is looking to, they have already developed, quite frankly, a essentially machine learning model based platform to sort of go in and audit that type of data and be able to predict some of the risk around that, actually. And so I'll be happy to share, and they would be happy to share, for me to share some of that information. And so we're actually talking about partnering. One of the things that we're building at NADPH is a direct-to-community health information network. And that's really to help patients, members of the community, right, better organize their health information across the information ecosystem, manage it, but then extract meaning of it. And the aim is to really make them more competent. And so we're looking at ways to impart robust technologies like that, again, just to make sure that we're getting the PII situation right. But I appreciate that question and happy to share that information because we are very cognizant of that.